So, hello everyone, and thank you for joining the CRID Webinar Series. We have really a great star with us, but I'm going to leave it to Professor Mohanna to actually introduce the whole session. So thank you, and the stage is yours, Professor Mohanna.
Thanks, George, and thank you so much for organizing this and creating this webinar series. And it's just a brilliant idea to bring guests to give a talk for our students and the community of AUD. And thanks, Manuel, for joining us today. And as Professor George mentioned, Manuel is kind of a star in a way. So, just to introduce a brief introduction for Manuel, he's a co-founder of and the principal of madMdesign, a computational design practice based in London. And he's the co-founder of the robotic manufacturing and design brand Nagamian. It's a well-known brand based in Avila in Spain. And his work has been exhibited worldwide in venues such as Centre Pompidou in Paris, Victoria Albert Museum, and Albert Museum in London, and Canada's Design Museum Toronto, and Royal Academy of Arts in London, and Zaha Hadid Gallery in London, as well as Philadelphia Museum of Art. Alongside his practice, Manuel is a lecturer in architecture at the Bartlett School of Architecture in London. He's a program director of the Master of Science and the Master of Research, and Architectural Computational, and the Unit Master of Research, Cluster 4, at the Master of Architectural Design, both part of the Bartlett B Pro. In addition, he's a co-founder of the UCL Design Computational Lab. He has previously taught at the Architectural Association School of Architecture in London, the Polytechnic University of Architecture, and the European University in Madrid. Manuel holds a master's degree in architecture and urbanism from the Architectural Association. And he worked as an architect with Richard Rogers in Richard Stirk Harbers and Partners and Minima Forms in London. I'm sure that's a brief introduction about you, Manuel, and you have much more interesting things to show us, and so maybe to introduce yourself as well. And I'll have to maybe step back for now and just give the stage is yours, Manuel, to start presenting.
And I would just like to remind you, question and answers, yes, please.
And I would like to remind you, I would just like to remind you, everyone, if you do have questions, please have them in the Q&A section, and I'll be reviewing them and I'll be asking Manuel once he's done with his research. Apart from that, just enjoy the informative talk of Manuel. Manuel, the stage is yours. Go ahead.
Yeah, thank you so much for the invitation and for the introduction. Yeah, that is actually the long introduction. Yes. So thank you. I got even exhausted to like hearing how many steps I've done. So I'm very tired now. You know, after all that. But hopefully there are many more and more exciting in the future. So yes, it's a pleasure to be with you all here. I'm gonna talk a little bit about not every single of those parts, but the main ones. So let me just share the screen first. Does this work? Yes, right?
Yes.
Okay, good. So yeah, well, I entitled this lecture "Designing for a New World." That has right now obvious reasons. The world is changing, but I actually think that the world has been changing for quite a while, and perhaps not at the right speed. And some of those developments in design and technology have been hidden or a little bit undercover, and now they're starting to raise and become one of the main tools that we have to fight this crisis. I'll tap into that a little bit more in a second. But basically, that has been always my aim: explore new technologies and new design methods through computation. And I've done that mainly in my three kind of hats, right? Which is my personal practice, madMdesign, and the research lab that I'm running with my colleagues at the Bartlett School of Architecture, and the robotic manufacturing company and design brand Nagami, right? But the three of them are sharing this interest in technology and automation, and to find design methods that actually respond to these advances and push them to the very limit to make architecture more sustainable. This is a little bit of a map of some of the projects that I've been working on in this, let's say, three sides, but they are all interconnected. It could be technology-wise, conceptually, or also in terms of manufacturing, as we will see in future projects. All of them and my entire research is revolving around the idea of making construction of buildings cheaper, more accessible, more versatile, and more democratic, just as digital data. Right? So I mean, this is a picture that we've seen already for quite a while, right? Decades. This is obviously a robotic manufacturing facility for cars, in this case Tesla. However, this is how construction is looking, at least in 99.9% of the cases. It's a very wasteful, dangerous task, and we could consider it dirty work, right? There's also many theories just saying that construction of big artifacts like buildings is actually just not made for humans, right? So we need to find a better way to deal with the scale we work with. At the same time, if you try to look for construction in this graph, this is the digitalization level in different industries. So you see construction is right at the very bottom, right above agriculture and hunting. This is for obvious reasons. Automating hunting is definitely not fun. So the construction, however, is most of the time is not fun and not safe to do. So we have a long way to walk through to introduce digitalization in architecture and construction, but and for many reasons that I will try to frame during this talk. So this is a house. This is modernism, right? One of the case study houses is a style house, right, in LA, in Beverly Hills, and right now we understand it as a very luxurious environment, but in reality, it was actually a house for a school teacher. Yeah. Times have changed, and obviously there's no school teacher nowadays that can afford such a house. But this is basically evidencing the main objective of modernism, right? And it was linked to Industrial Revolution. So basically, Industrial Revolution allowed us to repeat pieces and automate some, or in some way, its construction and its assembly. And the modernists basically took advantage of these developments to create a more affordable construction system. So they could industrialize these pieces, and they would become these kit of parts that you could assemble quickly and safer, and reduce the manufacturing cost of the architectural piece, like in this case. So this was actually not an expensive house to make. It's just the value of land made it unaffordable afterwards. But that was not the original idea. In contrast, again, this is a Tesla factory. So this is the state of the art of technology in general. And this was the state of the art of technology in the from the 1760 to 1820. So basically in the 1800s, this is how it was looking and how architecture was looking together with it, right? This is how technology looks today. However, this is actually the cutting edge in technology in architecture, right? So Catera is probably the only company, or at least the biggest company, that is trying to automate architecture. However, this is the architecture that we're trying to automate. It's the pure American dream. Is the house that we could draw when we are 5 years old, right? This is what we understand. And a space that we want to inhabit. Hence, that's what people understand is what we want to automate, right? But I do think that the automation is indeed a design problem. And this is an incredible opportunity to start designing with and for automated processes. Obviously, let's say the highest stage of automation is and will probably always be in a space exploration, right? And it has been there for a while. There are initiatives for these three main streams. Deployable structures that you can flat pack and deploy easily, like pneumatic structures. 3D printing, meaning structures that can be erected without humans in hostile environments without having to transport the material or transport pieces. And robotic assembly, meaning very densely packed set of pieces that can occupy a much larger space thanks to robotic deployability. And again, yeah, talking about the deployability, this hasn't been, or this has been actually present in architecture, especially from the 60s to 70s. So we have very old examples like Jose Miguel de Prada Pool, or more recent ones like Segascano, who are part of these Spaniard groups trying to work with pneumatic structures to deploy the spaces very quickly, easily, and cheaply. And so that's something that I worked a lot on, especially at the beginning of, or earliest stages of my career back 10 years ago, developing software for designing and creating and controlling structures that could be very, very easily deployed. Like in this case, this software is allowing you to design with a flexible membrane, but then it's also rationalizing the flexible members that would support this membrane. In this case, very, very incredibly cheap and accessible material or available material, like PVC pipes or fiber rods, or even bamboo. And I've been playing out this idea of the discrete and pieces that can be basically repeated and connected differently to create heterogeneity in the architecture, but to streamline the production and material efficiency. Introducing robotic methods and automation, like in this case here, trying to control the deformation of these pieces computationally. And this led to a series of pieces and exhibitions, like this one, for example, was in The Hague, trying to compute these different elements and put them together in such a way that they could actually be disassembled and reassembled, taking advantage of its flexibility. Like those pieces, for example, were moving from The Hague to Taiwan, well, the opposite way. And there's a series of pavilions and with different materials that suppose this investigation on the flexible members, sometimes linear, sometimes surface like in these cases here. how these linear elements could conform a structure that together with a larger surface of flexible fabric could remain in a structural equilibrium. Also with this idea of deployability, I've been playing around with pieces that could be very, very easily manufactured and repeated. But again, thanks to their flexibility and their connectivity, they could conform larger surfaces and erect larger structures, therefore, such as this pavilion that I did for the Tallinn Biennale competition. Unfortunately, I didn't win it. I was actually going to build a similar version in Abu Dhabi, which just didn't happen because of COVID, and hopefully we'll recover it in the near future. Also, more projects taking into account this idea of the deployability and flexibility of the space, like this one in Kuwait, where just in a week, because of the repetition of the same piece, we could accelerate the production at the very, very maximum to reach a very large scale. So this is made out of 4 single pieces that are repeating and connecting differently to change and vary the opacity and the performance of every single part of this envelope. And but that's something, this kind of material organization is something that I explore with different manufacturing methods. Sometimes it's pieces that you connect, sometimes it's pieces that you compute and print in one go. And I'll go a little bit farther on this, especially introducing the work that we're doing at Design Computation Lab, which focuses on elemental particles for the automation of architecture. So these are different assembly process or fabrication methods using robotics. But what is important is that to automate these processes, you need to conceive the elemental particle of those structures as something that could come from automation and that could be easily automated. That means if you create a limited number of pieces with a limited number of assembly possibilities, it is much easier to instruct a machine to follow that limited number of steps. And that's what we do. This is like how the studio normally looks, except these days, which obviously looks empty, and the robots are just missing students playing with them. But you can see different aggregation methods, and to be honest, they all kind of revolve around the same idea and a very, very similar syntax, independently of form, right? There are pieces that are conceived to be grabbed by an end effector, by a robot, and that could deal with the possibilities that this robot would have to assemble them together into larger structures. And we test that in the scale of furniture, but also in the scale, or let's say the maximum scale that we can achieve within the limitations that we have, but aiming to picture what this architecture could be in the real scale, right? So what we are testing here is a part of a larger system rather than an end product. Right? So in parallel to the research that we were doing at the lab, back in 2013, we started playing with the idea of having a parallel robotic manufacturing facility that would actually take some of these processes, especially 3D printing, to a commercial level. So in 2017, I finally got together with my brother and one of my best friends and started a crazy journey with these three main objectives. We wanted to achieve a high level of automation in design. We wanted to take advantage of distributed manufacturing, especially associated with 3D printing, and to perform a very, very short and sustainable production chain. So this is, in a way, and this is not just what we're doing in Nagami, but 3D printing in general, is kind of giving a completely new step to what we've been kind of almost using until now, and we keep using, which is the assembly line, right? And especially that goes together with a centralization idea. This started with John Ford, and that allowed to reduce manufacturing prices of automobiles to the very, very minimum, just because of the specialization of every single part of this production chain. However, this leads to a very long and wasteful process. You need to set up an entire factory with these different steps that are producing their own emissions. So the entire emissions of the factory are the sum of all of these singular elements. You need a high initial investment per product, right? You need to set up a specific machinery for the development of each of those products, right? And that could be molds, that could be assembly machines, and so on. And that leads to standardized products, right? So, because you've done this investment, and you can only produce this one product economically, you are tied to that product forever. 3D printing, and this is kind of our motives in Nagami, right? We can do a very, very, very short production chain, and which includes a circular economy, right? So we can recycle the material that we produce. We can do on-demand production, right? You know that so 3D printing, or a 3D printer, doesn't really care so much if you print one part and a completely different one right after, within limitations, and I will actually explain that a little bit further. So let's say you do have a level of customization that you can introduce in the product, and you can produce a different product every time, right? That is a high versatility that you don't have in the common long centralized factory. So this is actually our equivalent of this image right now. It's just one machine, infinite variation of products. So it is the complete opposite of the traditional idea of manufacturing products and architecture. And so we aim in the near future also to start getting advantage of the power of distributed digital manufacturing. Meaning you have one file, which is a digital file that can obviously be distributed instantaneously all around the world. And if you would have one 3D printer per country, or one 3D printer per city, you can actually simultaneously produce that file. At our scale, that is still something in progress. But at a smaller scale, it is actually something that has been very recently demonstrated widely, and is used in the world as the largest connected factory. We've all seen these images, and unfortunately, as a Spaniard, I started seeing them very, very early on. Medical equipment was urgently needed everywhere in the world, right, and in different stages. The virus, as you guys all know, started in China, right, where most of our centralized production is. So when it came here to Europe, basically we realized that, first of all, the productivity of those factories stopped because they just passed the crisis. And even if it wouldn't, they just didn't have the potential to produce as much medical equipment as was needed. So these are in Spanish, but these were the everyday announcement everywhere in the media. Doctors and nurses just shouting, asking for help because they were completely unprotected from the virus. At the same time, and this is actually an image from 6 years ago, right? So while people and governments were kind of trying to get stuff from China, as we did in the past, already 6 years ago, over 750 million people had access to a 3D printer within 10 miles from their home. Many of them obviously in their home. These numbers have obviously changed, but already 6 years ago, they had that landscape. So the entire maker community started to jump into the project immediately, thanks to the digital technology that they had, right? So in a matter of days, we started seeing 3D printed face shields, 3D printed masks, 3D printed parts for ventilators. And this was basically taking advantage of something inherited to 3D printing, right? You can 3D print a completely different product from one day to another. And you can produce it locally. So all these people were actually just producing for their local hospitals, reducing long-range shipping, emission, and shortening times incredibly dramatically, right? We obviously jumped on board with this call immediately and repurposed our factory in 24 hours to produce face shields. The advantage that we have as well, and so we made a kind of a redesign of the Prusa open source model. But because of our robotic manufacturing methods, we could actually print them in like 1 every 5 minutes, right? That is around 7 times faster than a desktop 3D printer. So this time, actually, our robots were not just allowing us to make bigger products, which they normally do, but they also allow us to produce much faster. And that was a crucial advantage that we had to deal with this situation very quickly. So we produce already more than 6,000 masks and serves hospitals in the entire country. And we work with an unfortunately limited material, this is again something inherited to the technology. Plastic, right? Plastic is everywhere, and unfortunately, it will always be. And in 2018, to give an example, 359 million tons of plastics were produced. 1/3 of those for single-use packaging, and only 10% was recycled. So that means that every year we are producing tons and tons and tons of material that if we don't reuse, it will actually generate an incredible waste. So we're working together with Parley for the Oceans, which is a global organization taking care of the survival of the oceans. So they collect plastic in the coastlines to clean the beaches and clean the oceans and transform them into beautiful products. So we're working together and using their awesome plastic to produce objects such as this face shield, but also many others, right? And this is well, the obvious goal of this process is people were feeling safer, and we were feeling safer because they were. And I think this is an image that we keep on receiving lots of these pictures, and we are extremely grateful to them to keep fighting in these difficult times. But at the same time, it's actually giving a lot of ideas on how digital manufacturing is changing the way we produce, the way we think about products, and the way we establish our production and design methods. So Nagami is focusing on not only the technology, right, but mainly the design aspects that you can explore through printing. We've been working on many different products and objects for exhibitions, just pushing in every single one of these products, pushing the technology, sorry, to the very limit, creating natures that were basically impossible to materialize without printing. So not only just trying to exhibit a process that would allow us to build faster, to build more sustainably, but it's also mainly a process that allows you to create things that you just couldn't even imagine before, right? And I think that's where 3D printing is starting to change the way we conceive design, right? So if automation, as I mentioned before, is a design problem, it's mainly a design opportunity. And the main question when you're starting this exploration is actually how to design for and with automation. So this is how our previous factory looked like when I'm moving. And we've been working a lot in this scale of products, but really exploring this plasticity of the material in many different ways. So we play with our manufacturing methods, for example, changing the pigmentation in the extruder. We work very closely with the robot to create objects that are every time a little bit different, right? So sometimes it's just us being next to the extruder, feeding different materials, playing with different opacities, and so on. And those are things that are implicitly inherited to 3D printing methods. So these are some of the products that we have currently in the catalog. And I think what is important, we didn't invent 3D printing, and that wasn't our intention. But 3D printing was, until now, at this scale, limited to pieces for galleries, museums, and collectors. And what we are trying is to optimize this process and exhibit it as the potential it has for changing design, but generating a range of products that are actually accessible to the public. Even if we have some of those pieces, the pieces in the screen are actually more for collector editions, but some others are actually accessible pieces of furniture that we can mass produce and that we can put in everyone's house, right? Which was something completely inaccessible to 3D printing before. We launched the company in 2018 with 4 pieces in collaboration with 3 of our colleagues and favorite designers ever. The first one was Daniel Wedrick, who was working on basically pushing the organic feeling of this surface to the limit, right? So this is really playing with the maximum angle that you can print without support material while keeping this extreme efficiency. So for this very large armchair, right, we can print it at an incredible speed just in 6 to 8 hours, which was something really unachievable before. Some of our other pieces, and I'll go through them in a second, are printed in only 3 to 4 hours. That means 4 times faster than printing the same piece, or actually it's even faster than printing the scale model of the chair. Like I have one here. This guy, this guy here, where is it? Well, you can't really see it in the screen so much. This guy here took actually longer to print in a MakerBot than printing the real scale chair. And I think that is giving us incredible opportunities. We work very closely with Ross Lovegrove, who we still work with in very, very exciting projects. And Ross was playing out this idea of a gradient, of different pigmentation of uniqueness. So every one of these tools has its unique kind of transitions that depend on the way you are crafting together with the robot this object. At the same time, we were working on the introduction of other materials, like for example, this silicon plaques. The work we did with Zaha Hadid architects is obviously exploring the form to the very limit, right? Which is something very characteristic of their work. So these pieces are varying dramatically from the back to the front, which pushed us to create a gradient in the deposition of material that goes from 0.5 millimeter to 9 millimeters in a single go. So 3D printing is not ever anymore this kind of horizontal slicing, but it's actually a 3-dimensional deposition of a varied thickness of material. And that is where these lines that you see, they become part of the design process, and you design for and with the lines. And for us, that is a magical transition that we're trying to do, since we are not only acknowledging that the material gets deposited in these thick linear fragments, but we are trying to push that as one of the properties of these objects. So we exhibited these 4 pieces in a Milan Design Week in 2018. And as I mentioned before, basically these were really pushing the technology at the beginning. So you can already observe many differences with what would be a scale-up version of an FDM conventional 3D printer. There is no 2-dimensional slicing, and the robot needs to basically find the perpendicular position to this printed line to extrude the material in the right way, and it's also extruding the material in this gradient of thickness, right? So there's much more to 3D printing than just getting any object, slice it, press play, send it to print, and that's it. So you can see this kind of organic effect of the material just running through this object without having this commonly found horizontal lines in printing. These are some of the objects that we then produce after Milan. So we went to Milan with prototypes, but then we were working on the actual objects that were exhibited in many places. Like this one is actually in Dubai. I finished last year. Then this one is in Zaha Hadid Gallery in London. But we also started working on collaborations with other brands for many different purposes, and sometimes having a very interesting twist to the nature of the objects that we produce. Like especially for some reason, we started collaborating a lot with car brands. Like this one is with BMW, and I'll let it play. Hopefully you can hear a little bit of the sound. These videos are all online, by the way, so I know that my connection in central London is pretty terrible. So if you are interested, just go to our website or to my Vimeo channel and check the videos online. Yeah, so that was this collaboration with BMW and in production. They basically got our objects and tinted them with the same paint that the car uses. Another car brand, Audi, also called us for participating in Dubai Design Week. I actually have quite a bit of work in Dubai. I really miss it. It's so unfortunate that this time is not in person. So this was for the Audi Pavilion in Design Week, and this demonstrated the main potential of our methods, right? This chair was just printed, each of those in 3.5 hours. So with 4 robots, we can serve an entire space in a matter of days. And that was something that allowed us to respond to this call very, very quickly, and to mass produce or slightly mass produce these objects for the exhibition. So as I was mentioning before, in just 3.5 hours, you have an object that you can just take. It doesn't have any post-processing. You take it, flip it, and sit on it. And that is for us a very magical moment. So we're producing some of these objects also, again, in collaboration with Parley, introducing their ocean plastic. This is making our already sustainable production chain even more sustainable. So we have a circular economy that we can get any prototype, strip it down again, and reinsert it in the production chain, right? But now we're also using recycled material from the ocean in that chain, and I think that brings a lot of new ideas on sustainability and circular economy that we are starting to explore further together with Parley in upcoming projects as well. And so the objects that we produce, as I mentioned, sometimes we still do objects or pieces for museums and exhibitions, but I think this is the magical moment. This is the game changer in 3D printing. When you start seeing 3D printed real products in people's homes, and I think that is an important inflection point in the way we conceive objects that we consume or normally, and not only for these special exhibitions and occasions, right? We've also done some very exciting collaborations on pushing this method to different environments. So this one is with Hassel for the NASA 3D printed habitat challenge, where we're proposing to print our objects already on site in Mars. So this is how Mars looks like. And so, of course, in Mars you have 3D printed Nagami furniture, right? But then, so the idea of this proposal is that obviously you don't want to ship unnecessary material to Mars, right? So what if you can get like your own waste or even soil to print products that could be altered every time, right? that could respond to different needs. So they do have this efficiency of manufacturing, but also this flexibility of being transformed. And that is something that is obviously not only important and advantageous for Mars habitat, but it is also a fundamental change here in planet Earth, right? So this was the Earth version of the Mars habitat that was exhibited in the Design Museum last year, where we were testing the performance of our products. And so as you've been seeing throughout the entire presentation, right, we check most of our methods in the furniture scale, and this is nothing new, right? Like we are all architects. Architects have always tested ideas in furniture pieces. You can see a very obvious example of Gary Ridel, but every single one, like Macintosh, Frangé, right, Gaudí, right? They could investigate those ideas, especially in chairs, because they do have these structural requirements, and they need that performance. But at the same time, there are smaller objects where you can check how your systems work and envision an idea on how they would work in a larger scale. So even if our factory has been looking like this mostly, it is also starting to look like that as well. This is a piece that we just recently completed with Ross Lovecroft, that is 3.5 meters long and is printed in only 48 hours in a single shot. Yeah. This is unprecedented, right? So it's a piece that is changing opacities, changing colors, and that is continuously printed in an incredibly short amount of time. And the next piece could actually be extremely different, right? And that is obviously a game changer at this scale with the introduction of 3D printing. So that is the 48 hours shot printing this object. This video is not online yet, so I can play it again. It's probably going in very slow steps, as you guys can see it right now. We're now completing the press release to publish this project very soon. So in this scale of architecture, we've also been collaborating with others, such as in here with the Norma Foster Foundation, with Xavier de Castellier, trying to see what an architectural 3D printed piece would be. So this was obviously a very, very exciting week, having the opportunity of getting this feedback from Sir Norman Foster, and also to explore these very, very different ideas on what 3D print could bring to a facade system, to a structural system. Could it be used for as a formwork to be cast? And all these questions are starting to emerge in the domain of architecture, and for us it's incredibly exciting. And this is really dealing with or approaching from a complete different angle how we can or should 3D print architecture. Like, and I'm saying a completely different angle because these were the very first examples or ideas about printing at an architectural scale. Which this was cosmetics in USC, and it's obviously a very interesting development, but it does pose some questions, right? Can we 3D print a building in one go? Well, yes, we can get the exact same method that we have in an FDM printer and scale it up to make it bigger than the building and then print the building. That has obviously proven to have limitations, right? And these are some of the results that we're we're getting from the US military, from Chinese companies, right? With questionable use of the technology. Do we really need to develop a 3D printing large scale method to print something that would look like any other house of any other material? And other more interesting examples are happening in research groups, such as Philip Bloch's or Benjamin Dillenberger in ETH, with offsites, very controlled printing, and then dealing with the assemblage of these 3D printed pieces on site. So let's say, and I will use some of these examples to illustrate this. These are the premises of 3D printing. On-demand production, right, with minimal waste. You don't have a stock, you just get asked to print something, you print that, you get asked to print something else, you print it again. A very short production chain with a low carbon footprint that we've been talking about in previous slides. The reduction of parts, right? You can integrate parts within the whole that you print. And a high level of customization, right? Well, the reduction of parts is something questionable, right? So obviously then you can't print the entire world in a single part. Architecture will always inevitably be inherited to the problem of parts and assemblies, right? As you can see in the way they are assembling this 3D printed. High level of customization. Well, these are some of the tests that we were doing for printing the Design Museum test loan. As you can see, the material can fail, the technology can fail, and it actually requires a long time prototyping to get to the right definition of a product. So for making this guy here, we actually needed 15 different prototypes, 495 kilos of plastic, 300 printing hours, and 3 months rationalizing and engineering these pieces. So you can customize it, yes. However, there are certain parameters that if you want to push the limit in every one of those pieces, you will need to take into account, and they will become a product development, right? So I would argue then that perhaps 3D printing is actually not the ultimate tool for variability. However, it actually has other more interesting even advantages. So whereas 3D printing has always been kind of associated to parametricism, right? To make different pieces over and over and over and over, and completely opposed to this idea of Fordism, of repetition of pieces. Actually, I do think that 3D printing is somewhere in between. You can produce different pieces, yes, but within certain parameters, and actually you need to get to the right one so that you can repeat it without going through a new prototyping phase every time. So I think this is a balance that is very interesting, and it's starting to give other design spaces for 3D printing, such as doing very, very like short editions, right? You can create a complete new piece from scratch for one building and repeat this piece, or you can make a piece that has a level of variation, but that works within a formal domain that you can control through a very efficient prototyping phase. So I think this is starting to become a kind of a new field for exploring with printing. And what it requires mainly is a serialization of errors, right? So the last thing you want to have in a 3D printing environment is to realize that there was a problem with the geometry, or that the angle was like a little bit too steep, so that this print fails after 48 hours printing, right? So I think there is an interesting aspect of design that goes from prototyping these pieces that is starting to generate its own kind of natural processes of making and formally expressing themselves. And with this issue, or with this aim to civilize errors, we utilize a discrete approach in the piece that we did together with my lab. So this is a collaboration with myself that we did for the Centre Pompidou, the voxel chair, that is using a single piece repeated throughout the volume, right? And this piece is, well, there are two kind of pieces, right? One that is giving more density, one that is leaving the parts way more porous, so that they can create this gradient of strength and opacity that is responding to the structural requirements of the object. But essentially, since the entire object is made out of these two different pieces, you just need to prototype those pieces before, those line fragments, in every single rotation. And you know you have the security that the print will be successful at every stage if it's all composed out of this single line that you have previously prototyped. So I think for us, this was a very, very interesting process on finding out the right workflow between making and designing and programming this expansion of this line into a larger object. So these are some stills of the voxel chair version 1. It is part of the permanent collection of the Centre Pompidou. So at a different scale, but also aiming to, again, civilize errors, right, and optimize the prototyping phase to the very maximum. We've been dealing with larger pieces that could be altered, but somehow repeated throughout an object. And we explored this method in the piece that we did for the V&A Museum called Nectary, which is basically making a variation of a single piece, right? So once we prototyped this like small guy there that you see on the right, we knew that we can then make it longer or shorter, but we had the security that it would actually work after the prototyping phase. And for us, that was fundamental to create a piece of such a scale. If every single corner would be different, we would be still prototyping today, right? So I think that was a very successful approach towards this question of the deployability of a larger structure in the museum, and it gives you this flexibility of spatial configurations, so that you can go from, let's say, from a piece of furniture to something much larger. That is what I proposed to the museum at first. Obviously, they said that they didn't have a space so big, but so this is and this is something that I continuously explore in most of our projects, which is how to computationally arrange these combinatorial processes and allow this intervention for how to combine these pieces in different structures, right? So this is a software that we developed to deal with these pieces. So you can put structural requirements or the volume that you want to fill with pieces, and it will automatically generate the best arrangement for you. The video is online, so you can check it. You're probably getting it in steps as well from my side also. Better go to our Vimeo channel. So this was the production. It was actually something incredibly fast. We were prototyping then the connection in between the pieces, something extremely straightforward. The pieces were designed to be simply printed and then very, very simply connected as well. So that is how we assembled this in the museum. And very, very, very quickly, just in a couple of hours. And and then we disassemble it. So this is the overnight version of this assembly with all the pieces that go back again to a truck, shipped to Prague, and then assembled again in a different configuration. Then this basically leads to the last project I'm going to show, and this is really work in progress. So these are actually just the earlier sketches, but so that you have an idea of where we are going towards in Nagami as well. This is the 3D printed house so it's basically taking advantage of this system to produce a habitable and inhabitable space. So based on this idea of transforming the assembly line into this like very compact part productor, right? Which is our own 3D printing cell, right? But it's also really rethinking shipping for prefabricated architecture. Some of our heroes who were basically thinking about design and production simultaneously, like Jean Prouvé. So he has his own he had his own factory for furniture, but he was thinking on having to ship these Maison Tropical houses in a large aircraft. However, thanks to distributed manufacturing, we could actually access a very similar machine and just send digital data over to that machine in any part of the world and produce those parts for construction locally. And I think that is a fundamental shift in the way we think about construction of buildings. And so this is just an example of a very simple piece that could be rotated and connected differently. And it could be very efficiently printed with a robot. So in this case, it's a 3-meter tall piece, just lower than the sculpture that I saw before. And it can produce all these kind of different configurations. So with a very short number or a limited number of pieces, you can actually produce not only larger spaces, but large variation of spaces. So these are the same pieces as this other prototype, right? And these are like also, it's starting to give interior qualities that, thanks to the material and to the assembly method, that are completely novel, right? And this is an inherited 3D printed architecture, yeah? And it's not taking any previous model and trying to replicate it through a different technology, but actually playing out the opportunities of this technology for creating a completely different design. And I think that is bringing new opportunities to the field. And we hope we can actually start rendering this in real matter in the coming months when COVID is hopefully a bit more controlled in Spain. So that's kind of the last project I wanted to show. If you guys want to learn a little bit more about what we've been working on in the lab, and other fields, and learn a bit more about how architecture will change with automation, you can get our latest book, Robotic Building: Architecture in the Age of Automation. And I don't have a slide for that right now, but we're still also accepting applications for architectural computation at the Barnard School of Architecture. So just check it out and reach out if you have any questions. If you want to immerse yourself in the world of computational design much deeper. And yeah, with that said, thank you so much. Now this is the awkward moment when you can only do digital claps and then I get read the questions. But I'm looking forward to your questions and to your feedback. Thank you. Check out our websites and social media, where you will actually find the videos in an appropriate quality. Yeah, not what I've been saying.
Thank you so much, Manuel, for this informative lecture. I think we got some questions coming in for you, Manuel. That was very informative, and I think all of us enjoyed it. So thank you again. So the first question says, how can we export the model from soft modeling to another software?
Ah, that's a tricky one. Well, so soft modeling, I mean, it's still open source. It's still online. You can find it in my GitHub, but it is a bit tricky to install, and then it does have, you need to read the code. It does have an exporting shortcut in the, yeah, so it's somewhere in the key assets, right? So I think I didn't get to the stage of well, there's a record button though, and that generates, I think, an OBJ file and a text file, and then the text file is giving you the position of the points so that you can recreate the lines. It's not really straightforward. It's a kind of a software in development, lately in very slow development. If you want more information, just reach out, send me an email, and I can try to answer. And I'm glad that you are already using that software. It's again even very tricky to install because you need to clone the repository and so on. So already installing it means that you are interested in learning how to program. So I'm glad you are going that path.
All right, just the next question is from one of our students, Ahmed Mansour. He's asking, do you think the assembly of pieces approach could lead us to design new kind of living in residential buildings? Can this change the way we design and have been designing for decades, the house and spaces and get into our living style, or is it more suitable for pavilions or light structure to start with?
Yeah, I think that's a very interesting question. So actually, most of our research is focusing on housing. And I'm not showing the latest development of the lab in this presentation, but we're publishing those projects regularly in b-pro.org. Yeah, so you should check it out. We are actually currently experimenting with the automation not only in production. Yeah, so obviously, you know, structures are versatile enough to produce housing buildings as well, right? And that is something that we're exploring. But we're also exploring very consciously different modes of living thanks to this automation processes. For example, what if the building is still alive, if these pieces could be then taken apart, reassembled, or if there is a level of automation that is allowing you to customize the space. Like some of our projects are dealing with, let's say, 24-hour occupancy in housing buildings due to, or thanks to the transformability of the space. So what if when you're leaving your house, that same space could be reconfigured or combined with other spaces to then become offices for someone else, to be an addition to another apartment, and so on, and how that is transforming the way we live our spaces, which I think is a very important question that is responding to new needs, right, in the current society. And we do that also through the development of platforms. So we pose questions of, you know, ownership, like who is actually owning the platform? Do you have a landlord? Are you owning part of this building? Are you owning pieces of the building, right? And how that is creating a new socioeconomic model, which I think we will be seeing much more, especially after this crisis pass and we start rethinking the way we build, the way we design, but obviously we are already rethinking the way we live. So right. It's kind of a topic for another lecture, the entire housing agenda.
I hope we can get to you one more time later on, maybe. So the next question from Professor Say. Hi, Professor Jose. So Professor Jose is asking, how was your business start to set up a company with such high tech investment?
Mm-hmm. That is also a very, very interesting one. And obviously, you know, that life with the startup is an uncertain territory every day. We started very low key. So in 2013 we started playing with robots at the bar. Like we had this very tiny ABB. And we started kind of getting our head around what you can do with these processes and testing it in furniture. One day, we just had a crazy idea of doing this parallel version that would generate a more robust piece of technology that could print real products, right? And we started as most startups start, right? Like just with some of our own funding and credits from banks, and getting literally a garage, a second-hand robot, and developing our own extruder in my brother's apartment that still smells like plastic. And it's been a long way from then. It's the second time we moved factory. Now we're moving to a 2,000 square meter factory, and hopefully adding more robots. And we are now in the third version of that extruder. So the latest versions are professionally manufactured according to our design. But to design the good extrusion process that looks something like simple enough. Like at the beginning we thought, wow, you can just buy extruder. Not really for this specific process. You want to really control it to get the quality that is needed in a product that will be in the market, right? Like we can't produce like prototypes, right? Like these pieces that you normally see made with a maker bot. This needs to have another quality, and so it took us a few years to get to the right mechanics to have the perfect extruder for us, right? So yeah, and we keep on developing it, and right now we're also looking into expanding the business with external investment and so on. But it was pretty much a family business that started in a garage, and it's still kind of there, even if it's obviously getting much bigger.
All right, I think we don't want to keep you for a long time, Manuel. So I'm just going to go through the remaining questions in a quick way. So Delicia, she's asking, are the software of the voxel chair is an open source as well?
Not that one. That one is also because it's still under development. So this CRID design software has been through 2 iterations, it's 1.0 and 2.0. And now we're working on the third version that will probably be open source. But not yet, because that's it's still a really messy development. So right now it's linked and tied to the specific project, and is part of the project itself.
All right.
Some of the methods are, however, explained in our papers, so they are replicatable. So you can go through our academia profile and learn more about how the software works.
All right. The next question from Professor Alex. Hello, Professor Alex. So he's asking you, are there any companies similar to Nagami that they are currently competing with you in your business?
Yes, not many, right? So we are not the only large-scale 3D printing company in the world. Our focus is very particular, though. So most of those companies, I mean, there's like a handful of companies in the world now doing this kind of work. Most of them are service-based, right? So they 3D print things in demand, taking them as projects. We also do that. But for us, it's also very important to keep this focus as a design brand that is producing products, even architectural products, right? So with that kind of symbiosis between design brand and robotic manufacturing company, I think we have still a very unique profile that we will try to push much farther. yeah, I think that the 3D printing community generally is expanding, and that is a very good thing. So I'm happy that I see more people around the world printing with robots. For us, the products themselves are of high importance, and interestingly enough, I think when this technology becomes truly democratized, right, and no one talks about 3D printing anymore because we assume it's 3D printed. It's like, I don't know, in dentistry or in Geoli, right? Like most of it is 3D printed, but you don't talk about 3D printing. It's like we don't talk about a plotter, right? We don't talk about 2D printing these days. There will be one day when the technology is completely assumed as part of our common production methods, and what will last is the design we do with it, and we intend to have these pieces that survive different eras even after this particular technology is not as catchy and attractive anymore, but it just becomes normal.
All right, thank you for the answer. I think I have two more questions. The next one is from Simon about the distributed factories. How do you approach the problem of uniformity of the tools and the process to guarantee the feasibility of the manufacturing anywhere? So will it need to have the same end effector, same robots, same environment, and common training, or do you think it could be more flexible?
Yeah, yes and yes. It's kind of in between both. Well, we're now, and we're in conversations with different companies to do an international expansion, right? So right now our extruder is quite particular. So how we envision horizon one of this distributed manufacturing step is just having any robot. I mean, the robot is something that you can just find, right? Like it doesn't really matter. What matters is that, I mean, the robot has the capacity to print in this range, and it has enough payload to carry the extruder, but that's it. But I think the extruder right now is the part of the technology that needs to be kept in the same conditions, right? So therefore, our conversations are now about us shipping an Agami extruder where this new 3D printing cell will be situated, and not just using your own extruder. Obviously, with that, again, with development, and there will be more and more extruders just coming out, and perhaps in a few years from now, something that is accessible in the market, and then our contribution is also in the way you can design with it and compute for the 3D printing methods, designing tools that are open enough to different pieces of technology, right? So we envision a software where you can get your design translated into robotic instructions, where you introduce, you know, the robot that you are using and the extruder that you are using, and so on. Right now, this is really a research field, so you know it is limited the kind of tools that you can use. So if you want to print Agami products, I think at this stage you should use an Agami extruder. Yeah.
Okay. The last question I have, Manuel, for you, from Ray. She's saying, or he's saying, hi there. Thank you for an amazing and innovative lecture. Would this way of design or constructing be feasible in renovation, refurbishment projects? What challenges would be faced?
In innovation and refurbishment?
Yes.
Yeah, actually, because refurbishment is actually a very, very interesting one. We have some projects with more in the research lab with the students on how to use 3D printing in combination with existing pieces, right? So obviously, one of the advantages of 3D printing is that you can produce custom design, right? So I mean, it doesn't even have to be that your building is falling apart and you want to renovate it. You can also create very specific design for different parts of your space, thanks to printing. I think we actually have like a few projects around this topic on how to allow for this level of customization, yeah, where the user is kind of saying the gap that they want to fill, and that gap being structural or being furniture or being something else, and our software basically deploying a modification of a design that is previously tested to fill that gap. And I think that is a very interesting domain. So it's not constantly creating something from scratch, but using this adaptation inherited to printing that could generate an entire repertoire of structural pieces, furniture pieces, and other kind of pieces that could be personalized for one specific space. So this is something that is an obvious route of 3D printing larger scale. It's still very challenging, but it's something that we are actually very excitingly working on.
All right, thanks, Manuel.
Okay, I have some questions, if you don't mind. There's still more questions?
One more question from Professor Jose
Sure.
again.
Okay, then after him, I have 3 questions. If Manuel doesn't mind, can we keep you for just a few more minutes?
It's
perfect. Go ahead.
Yes, the last question from Professor Jose. Do you find coding as a generalized core subject in architecture schools in the near future?
Yes, absolutely yes. I mean, coding should actually be taught, and it is in many cases. It should be taught in high school. To be honest, I think new generations should start learning how to code when they're like 2-3 years old. For architecture, it's fundamental, 100%. And it's not only because we are actually closer to technology, right? Like this is a new domain for architects, right? Like, so let's say, I mean, we did have the master builders. This is also like a topic for another lecture, but so we had the master builders, right? Like Brunelleschi, you know, that were dealing with making, right? We're designing, making, testing, prototyping, breaking, building again, right? So the architect was the master builder, right? Then that kind of image started to get dissolved to architects making representation for someone else to build, right? And that is where we've been for a very long time, right? And that's why, you know, an architectural office is, you know, producing plans and sections and 3-dimensional models to then be constructed by someone else. Now I think we're kind of like coming back to those previous like master builder moments, together with some examples in revolutionary examples in the past, such as Miguel Fisac or Jean Prouvé, right, where the architect gets much closer to the matter they are building, right, and to the point that they become the builder themselves. And this is empowering our discipline massively, not only to not depend on so many external factors, but also to push design ideas that no one would actually push for us, right? And I think that's important. And to get to that stage, with the current stage of technology, we need to understand computation at the very core. We need to deal with it as an everyday tool. There is no escape to that. Like every single project we do has its own code at many different levels. Sometimes just for manufacturing, sometimes design to manufacturing, sometimes it's everything together. And that is fundamental. It's also something that you see changing in the mentality massively. Like we see our students to change the way they think about architecture when they start to learn computational processes and they start to learn how to code. It's not only just to master the tool, but it's also to open up new ideas on how to think in architecture. When you talk about automation, this is massively important, right? Automating a process, but for automating a process, you need to design for that process and stages in very small steps. It is a real computational way of thinking. And you will never make an automated construction process or an automated building without having that mentality. And that mentality you access through fighting with learning how to code. So yeah, a message for everyone. Yes, you should definitely learn how to code. Even if you will not code, you should learn how to code.
Yeah. Professor George, I had one new question.
Sure, go ahead, because I think this question follows up on...
Yes, on the previous one. So what coding language do you think is the most useful to learn and to apply in the architectural field?
Well, that is a very tricky one, right? So, I mean, it depends on what you are doing. I started learning with Java, which is, if you want to learn how to code, then that's one of the most accessible languages. Right now, game engines are becoming highly popular in architecture for obvious reasons, right? You have real-time rendering, and so you have a kind of a more active symbiosis with the models that you create, right? And you know, architects are very visually trained, so you can have that feedback. So I think like C# in Unity is proven to become very handy. There is also an entire new field for design related to machine learning, which I think is incredibly interesting and is again the topic for another lecture. And that is using a lot of Python. So I mean, it really depends. To be honest, learning how to code is learning how to code. You know, you can learn in Java, but then you can translate it to, well, to C++. It's a bit harder because of pointers, but you can translate it to C#. It's very similar. It's just a slightly different syntax. It's always like learning how to speak. You can learn how to speak in Spanish and then shift to Italian. That's a very easy one. In a matter of months, right? Because you know the structure of the thoughts for speaking, right? So I think that is the, like I changed to, I remember when I changed to Python in one day, right? So I learned Python in a day. It's not that I learned how to code in a day, that's not possible, but I knew how to code, and then you get into a new syntax and you just connect the dots. So yeah. So if you're starting, maybe Java, C# are still the easiest one.
So once you learn the principles and fundamentals of coding, then you can change, or you have the room or the space to change in between the different ones. I think, Mr. George, you do have questions.
Yes, first, Manuel, really fantastic and impressive presentation. I really enjoyed every minute of it. So thank you so much for doing this, and thank you for doing what you're doing. I think I couldn't find a loophole in what you're doing, and I think please keep doing what you're doing, because it's on so many levels. You know, I believe it's the future, and I love the idea of the kits of part and how you could. You know, 3D printed anywhere in the world. It's like kind of like a teleportation. I mean, you know, you could think it's crazy, the idea of teleportation, but creating a digital something, printing it anywhere in the world, that's actually teleportation in a sense. I mean, you teleport a copy, but you still teleport a piece. And I think that's really fantastic. I have a question, because I'm interested in knowing about the material and the weight and the durability of what you're doing, in a sense that let's say if you do the same chair or the same piece in other material, or not in 3D printing it, what is the light compared? I mean, how light is it? I mean, what is the weight compared to something done with the same size, 3D or 3D printed or not 3D printed? Do you have any idea about that?
Yeah, that is a very interesting one and very difficult to answer. So the world of plastics, which I didn't know when I started this, the world of plastics is huge. Like, it's incredible. And each of those plastics are, like, a new plastic is a new development. But they're like, when we talk to providers, and we have plenty of them, so
there are plastics that are heavier, lighter. There are plastics that look and weight like metal. There are plastics that are more flexible, less. And yeah, each of those, when it's not that you get the plastic through the extruder and then it just works, right? So when we change material, like we recently changed from PLA to PETG, and then to recycled PETG, and then to PETG mixed with PET. Every one of those steps was like a few months development, changes in the extruder, changes in the coating. So each plastic is a complete new world. I think it is, so right now we're using mainly PETG, which is an incredibly sustainable material. And it is a 95% the transparency of plastic, which is of glass, which is amazing. And it's also high strength, highly durable, suitable for outdoors. It's easy, so relatively easy. So that's like the golden state of plastics right now. But we're also investigating with other materials. You can print, I think that many of our designs, I mean, you could also print them in concrete, you could print them in other materials, but sometimes this change of material, this change of lightness and weight would lead to a transformation in the object as well. And I think that's interesting. So what we produce now, we produce it with and for what the technology that we have, right? But this could be definitely open up to like 1,000 million possibilities on different materials, which hopefully that happens in the future. Because the other question there is obviously multi-materiality, right? That we've been all discussing for a very long time in the world of 3D printing. So can you have multi-nozzle, right? Like, could you print the circuits within the product and things like that? I think those at a larger scale at least are still years ahead because of what I've been describing now. Like each new extrusion system is a new development. But I think that will be the real game changer, or the 3.0 game change in 3D printing at a larger scale.
So Manuel, weight-wise, so can we say it's 20% the weight, is 50% the weight? What is the lightest weight you were able to produce?
30% compared to?
Yeah, compared, let's say, for example, if you're 3D printing a chair, if you say you're not using this plastic, you're not using this material, let's say you're using wood or you're using any type of material, what is the light, how lighter it is compared to the normal one, let's say? Because you showed the conventional chairs that architects design, and then what you're doing now. So if we compare them, can we say you're 50% less as a weight, or do you have any idea about that?
Yeah, so not necessarily. It really depends on, I mean, it would obviously be much lighter than a concrete chair, and it would be much lighter than a massive piece of wood. Plastic is actually not light. We understand plastic as light because we normally deal with very, very thin layers. When you are 3D printing, you are actually depositing larger amount of material. So I mean, these chairs, they range from 8 kilos upwards, right? Okay. So it really depends on the chair. Like some of them actually, like magically enough, like from everything that I've been showing, like for example, the Zaha Hadid chair is actually very, very light. It doesn't look like, but it's very light. And then my chairs are actually heavier. So it really depends. You can also make compromises depending on the effect that you want to achieve. Like, for instance, if you want a very, very thin chair, then you need to print thinner, then you are gonna take longer to print. Depending on the geometry, is gonna lose strength, right? So it is something that you compute as well. Like, as I was mentioning before, we can print from 0.5 millimeter to 9 millimeters, or even to 12 millimeters, right? So it really depends on the effect that you want to achieve. Yeah.
if you are creating just like a panel or like some of those experiments we were doing with Norman Foster Foundation for facades, you can go very thin as well, right? Okay. But yeah, it depends. I think something very important is actually the flexibility of this method, right?
Yes.
The fact that you can control the amount of material that you extrude in every voxel of a space, right? I think that is very, very powerful.
Yes.
Okay.
Great.
Thank you.
Thank you. I'm done with my questions. Thank you so much.
Thank you so much, George, Professor George, and thank you so much, Manuel, for joining us today. I think that was a very informative talk and very informative lecture. Maybe opened some new languages, I would say, of architecture for the students and all the audience that joined us today. And I would like to thank also, so thank you so much for Manuel for joining us today, and hopefully we have more collaborations in the future. And thank you so much, Professor George, for organizing this session. And I would like to thank everyone who joined us today and asked me questions. So thank you, everyone. And I think that's it from my side, and that's it for the session. So thank you all.